So question number 2. A conical pendulum with the L equals 0.32 meter makes an angle theta equals 25 degree with the vertical. So the pendulum is going to undergo a circular motion in a horizontal plane. So this will be the center of the circle. So that's very important. You know where the center is. So then you know where the centripetal force should point to, or the centripetal acceleration should point to. And then always free body diagram. You don't start any work before you draw a free body diagram. So then we can tell what kind of force is acting on the object, the little ball here. So if this is object, obviously we have a tension force. Don't forget the angle here. This is a theta 25 degree, and you have Fg. So that's only two forces in black. And then I resolve the Ft into vertical component and the horizontal component. Now the horizontal component is chosen because that's where the direction pointing to the center, which is centripetal. So I put the x and y reference here. So in a circular motion, one of the direction has to be chosen to point to the center. So that's why I choose horizontal. And then look at the horizontal direction. You can see there's only one force, Ft sine theta, the component of Ft. So since that's the only force, so it should be the net centripetal force, so E equals mv squared over r, because we know this is actually the application of Newton's second law, net force equals ma. And then look at the y direction. Since the y direction is the motion is in this plane, we don't even have any displacement in this direction. So there's no acceleration. So that these two forces must be balanced. So we let Ft cos theta equals mg. Now since you got these two equations, a lot of different ways to solve for the v. You can find out the Ft from the second equation and substitute into the first equation. And the way I do is I like to divide these two equations so that I cancel the Ft, now when you divide, and sine theta over cos theta equals tangent theta. You don't have to change the tangent theta, you can keep sine theta over cos theta, okay? And then on the left right side you cancel the m, so then just do the simplify. You should have put this rg together like this, and the square root is the isolate v squared, then square root it, so you get a v equals rg tangent theta. Okay, and then since you got the v, you don't have to plug in everything to calculate the v for now, because the question really asking for period and the angular speed. So we go ahead and try to find out the period. Period equals 2 pi r, that's the circumference over the speed. And then we just plug everything in to simplify. And here is something we actually don't know directly, so which is r. So look at this triangle. So r is obviously equals L multiplied sine theta. So if we plug in here, and then you can see the tangent theta is actually equal sine theta over cos theta. You can cancel the sine theta and then flip over the cos theta. Anyway, you can do your way to figure this out. Eventually you should get this. And that's where you should plug in all the numbers. Okay, simplified everything, and then you don't have to do some duplicating in terms of calculation. Okay, plug everything in, calculate, you got 1.1 second for the period. And then the angular speed, as we already explained in class, is equals 2 pi over t, and which is the definition of the angular speed, right? The angle swept in one rotation, which is 2 pi, divided by the time it takes to do that. So that's the period of t. So you should get this as your answer.